Unit 6, Part 5, we're talking about logical implication, right? One formula does logically imply a second formula if, when you build their truth table, the first formula does logically imply the second, so long as you don't have any rows where the first is true and the second is false, right? So if you're asked, does the first formula imply the second? You just compute the truth tables in the joint truth table. You, like a terminator, look out for t going to f. If there is a case of t going to f, that means no, it doesn't logically imply, right? Don't get confused and think, I'm looking for a t and f to see that if it does, and if there is one there, then it does logically imply. But think about what logical implication means. No, it should rule it out. T going to f rules out logical implication. Logical implication is truth preservation. The existence of a row where true goes to false means it isn't truth preserving. You're going from true to false, which is the opposite of truth preservation, okay? So if there is a true to false, it doesn't logically imply. And the important thing to grasp that people get confused on, if there is no row with true going to false, no matter what else it is, if there is no row with true going to false, then the first does logically imply the second, okay? So I could ask, as I say, the exercise question and the questions in example 1 are very good for hammering home your understanding of this, right? So let me ask you, pause it after the question, does a contradiction imply a tautology? Right? Questions like this, you just want to think the image, right? Think the think the concept as per its truth table definition and apply the definitions. I'm asking, does a contradiction imply a tautology? Well, what is a contradiction? You just think F, 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 right? It's where the column under the major operator is all false. That's thinking contradiction as per its truth table definition. And tautology is true, 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 right? Does 1 logically imply 2? Okay, how do I answer that question? I just apply the definition. Is there any cases where the first is true and the second is false? Answer, no. Therefore, yes, 1 does logically imply 2, right? I am preserving truth, as it were, going from an instance of 1 to an instance of 2, right? Insofar as at least I'm not ever going from a true to a false. I'm not failing to preserve truth, right? Does a contradiction logically imply another contradiction? Yes. Just think, this is all false, this is all false. There are no instances of true going to false, and if there are no instances of true going to false, you do have logical implication, right? So, all right, so that's what you have to think for that. It's not a symmetrical relation, as we were saying, right? So, one can logically, so it's in a sense, it's a harder to understand, but it's a weaker relation than logical equivalence. Logical equivalence is stronger. They have to be identical truth table columns. One can logically imply 2, and usually does, with different columns, so instances of different, for example, the contradiction in the tautology, there's very different columns. 1 does logically imply 2. Okay. By the way, does 2 logically imply 1? Pause, answer. No, 2 clearly does not logically imply 1, because there is an instance of a true going to a false. Now we're thinking this way, right? In fact, every row is an instance of true going to false. Be clear also that a logical, right, one single row, even in a truth table of 32 columns or whatever, however many, just one single row of true going to false is enough to negate logical implication. It's enough to rule out logical implication. Just like in a truth table, all premises true and conclusion false is, that is one counterexample, is enough to show that the whole argument form is invalid, and thus every instance of that argument form is invalid. Of of course, the concept of validity is very much of a piece with the concept of logical implication, right? An argument is valid if and only if the premises logically imply the conclusion. Right? Think about the definitions of logical validity as per the truth table concept, right? In terms of a counterexample as a row in a truth table with true, all true premises, false conclusion. Think about that. Think about the definition of logical implication, and you'll see they match, and as it should, because those are the words we use, right? A valid argument, a logically valid argument, is one where the premises logically imply the conclusion. That is, it's not possible for the first to be true and the second to be false, or the premises to be true and the conclusion false. Again, study questions and exercise 1, very good at hammering home all this knowledge. Okay, let me do one. Test, this is 4B. Here are 2 statement forms. Does 1 logically imply 2? Does 2 logically imply 1? Both, neither, right? Okay, look where I put the 1 and the 2 here. I have to determine what the major operator is. We should all be able to do this. The major operator, this is a hook, right? So it does 1, so this is going to be the column that I look at. It'll be the last in my order of computation. Does 1 logically imply 2? What's 2? Is it a disjunction? Is it P or Q hook Q? No, it's a conditional, so that's 2, right? So let's compute it. I've got the P, Q, I've got 2 sentential variables, so P, Q, done my base columns. Let's compute them. Okay, I've got to compute the subformulas, so I've got to compute that. To know the consequent overall, I've got to compute that, and then, so I've got to compute that, and then that, and then I look at these 2 columns, and I'll compute this. Okay, so let's do it. Not P is the opposite of P. False, true, true, false, 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 true, true. P or Q, true, 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 false. Not P or Q, so I'm looking at this, not T, false, true, true, true. Now, for the hook, I'm looking at this and this. It's this, hook, this hook, this hook, this. Right? Don't make any silly mistakes. Check your work in your exams, because you'll one or two times you'll jump over and look at this. Make sure you're looking at the right ones. False hook false is true. False hook true is true. True. Did I make a mistake? True hook. Oh. True. True. Is this a tautology? I get this wrong.